Hi students, today I am going to discuss about the Kronig-Penny Model question. It is an essay question in band theory of solids chapter. Actually, this question carries 10 marks in BTech. Of course, it is very important in BSc also. Now, I'll explain the concept of this question. So first the introduction is, it is assumed that quantum free electron theory of metals that are free electrons in metal express a constant zero potential and is free to move in the metal. This theory explains successfully most of the phenomena of solids, but it could not explain why some solids are good conductors and some others are insulators and semiconductors. This can be understood successfully by using band theory of solids. So actually this para, it is belongs to the classical free electron theory. In classical free electron theory, Drew Lorentz explained the electron behaves like a gas molecule in a container. So that's why, and this classical free electron theory was failed to explain about the types of conductors. That means why a material allows current, why a material is not allows, why certain materials allows partially current through it. So that's why it was failure. Then a band theory was explained by Bloch. So in this band theory, this is the question: Kronig-Penny model. According to this theory, electrons moves in a periodic potential produced by positive ion cores. The potential of the electron varies periodically with periodicity of ion core, and the potential energy of the electron is zero near the nucleus of the positive ion core and maximum when it is lying between the adjacent nuclei, which are separated by the interatomic spacing small a. Let us suppose here this is x indicates the displacement and v indicates the potential. Let us take a linear chain of potential wells. This is one potential well, this is potential well, this is one potential well. In between two successive potential wells, there will be a potential barrier. This is the inverted potential well is called a potential barrier. Then if this is an ion core and this is an ion core, here the potential will be minimum, but in between these two ion cores, it means these two atoms, the potential will be maximum. That's why electron exhibits different masses at different positions. Here electron exhibits nearby, that means very much nearby atom, it exhibits a certain mass, and in between these two atoms it exhibits different mass. That is called the effective mass of the electron. Let us examine this question. I have to consider these two regions. This O, this is A, represents a potential well. You know, well, actually in quantum mechanics I explained about potential wells. So OA represents a potential well, the width of the or the length of the potential well, and here O and minus B represents a potential barrier. Here inside the potential well, the potential is equal to 0. Then outside the potential well, the potential is infinity. But here in case of potential barrier, here at the top it indicates V is equal to V naught. Here V is equal to 0. Now we have to consider these two regions. Apply the Schrodinger's time independent equation to these two regions. Then solve it. Apply the Schrodinger's time independent wave equation for the above regions. We know the one-dimensional Schrodinger's time independent wave equation, dou square psi by dou x square plus 2m by h square into e minus v into psi is equal to 0. This is Schrodinger's time independent wave equation. Now apply this equation with region 1. According to region 1, the v is equal to 0. Region 1 indicates from 0 to a, that is 0 to a represents a potential well. For potential well, inside the potential well, the potential v is equal to 0. Now apply this 0 here. Then this equation becomes this. For region 1, this equation will be like this. For region 2, v is equal to v naught for a potential barrier. Then this equation becomes dou square psi by dou x square plus 2m by h cross square into e minus v naught into psi is equal to 0. This is second equation. Okay. Then because since v is equal to v naught, we know this. Then put alpha square is equal to 2me by h cross square and beta square is equal to minus 2m by h cross square into e minus v naught. Then substitute this alpha square at this situation and beta square at this situation. Then these equations 1 and 2 becomes like this, 3 and 4. Dou square psi by dou x square alpha square psi is equal to 0. Dou square psi by dou x square minus beta square into psi. This is equation number 4. Here these two equations are second order differential equations. So I have to solve these equations by using a certain particular solution. For that, we have to assume a complex number, that is psi is equal to, let psi is equal to e power ikx into ukx. This is equation number 5 with the solution of equation 3 and equation 4. Here this UK, U means potential, K means wave number, means this UK indicates the periodicity here. That means the periodicity, the maximum potential and minimum potential, maximum potential and minimum potential along the x direction. So psi is equal to e power ikx into ukx. This is equation number 5. Now differentiate this equation with respect to x, because along the x-axis at different positions this shows different potential values. So I have to differentiate. This is similar to uv, udv. That means in this manner I have to differentiate this equation. Dou psi by dx is equal to d by dx of e power. That means this is like u, this is v, uv. Then differentiate this equation, e power ikx d by dx into ukx plus ukx into d by dx of e power ikx. Then this equation becomes like this, dou psi d psi by dx is equal to e power ikx into duk by dx plus uk ik e power ikx. Then differentiate. That means what we are doing, we assumed a solution here is a solution here, and we have to differentiate twice, and then this becomes d square psi by dx square. Then this d square psi by dx square should be substituted here, here and here. That is our main aim. Okay, now again differentiate. This is one uv, here also this is u, this will be v. Again differentiate with respect to x. D square psi by dx square e power ikx d square uk by dx square duk by dx e power I into k e power ikx plus this uv manner. You have to solve this. Then we will be getting this equation 6. Okay, I got equation 6. Now put equation 6 in equation 3. That is equation 3 is, this is equation 3. Now put this equation 6 in equation 3. Then that equation like this. Then at the position of alpha square, we have to put alpha square psi. At the position of this psi, we have to put this equation here. Then by putting this equation, now the common factor is e power ikx. So terminate e power ikx from this equation. That's why we have to divide the entire equation with e power ikx. Then d square uk by dx square plus ik duk by dx minus k square uk plus ik duk by dx alpha square into uk is equal to 0. This is the equation. We get d square uk by dx square plus ik duk by dx minus k square uk plus ik duk by dx plus alpha square uk is equal to 0. D square uk by dx square plus 2 ik duk by dx. Then add these two ik, this value and this value added. Then we get 2 ik and take a common factor of uk, then alpha square minus k square. This is equation number 7. Again now we have to put the equation 6. This is the equation 6 in the equation number 4. In this equation we will be getting similarly by putting here, and we will get this equation number 8. This is equation number 8. Now from equation 7 and 8, let the general solution of equation 7 and 8. I have to assume these general equations. This 9 and 10 are two general equations. By solving this 9 and 10, we will get a plus b is equal to c plus d. By solving the above equation at boundary conditions, at a certain boundary condition, boundary means at a and minus b. These are the boundaries conditions. We will be getting alpha square plus beta square sin h beta b sin alpha a by alpha beta plus cos h beta b cos alpha a is equal to cos k into a plus b. By solving the above equation, we get mv naught b alpha h cross square sin alpha a cos alpha a is equal to cos k. This is equation number 11. Then mv naught ba sin alpha a alpha h cross square cos alpha a is equal to cos ka. Now we have to assume p is equal to mv naught ba by h cross square. That is p. Okay, m means mass, v naught means the potential of the potential barrier, ba boundaries, h cross h by 2 pi here. By solving this, by putting here, we will get this equation p by p sin alpha a by alpha a plus cos alpha a is equal to cos k. Okay, so we'll get this equation, very simple equation. These we have to by heart. If you don't know this, you have to by heart, otherwise leave it. Right up to here by heart, and write these two equations from this equation, and write by solving the above two equation we get, and directly write this equation. Okay, then now case 1, in that equation put p tends to infinity, then sin alpha is equal to 0, alpha is equal to n pi, alpha is equal to n pi by a, that means square it, and then put equate this alpha square with equation 3, that is alpha square, that is from equation 3 alpha square is equal to 2 mu by h cross square, then equate this alpha square and this alpha square, we will get e value, e is equal to n square pi square, like this. Finally, by solving this equation, we will get e is equal to n square h square by 8ma square. N means order. Here n is equal to 1, 2, 3, 4 and so on. H means Planck's constant. M means mass of the electron. A means the interatomic distance, or the distance between two lattice points. This equation is similar to the energy levels of the potential well. We know h by 2 pi can be written as h cross according to Bohr. Now, the energy levels in this case are discrete. We know in potential well, I explained that the energy levels are discrete energy levels. The energy levels in this case, discrete energy levels, the result is similar to the energy levels of particle at constant potential box of atomic dimensions. This indicates the nature of the insulator. Then case 2. Case 2. Suppose P tends to 0. In previous equation, you put 0. Then cos alpha A is equal to cos Ka. Then alpha is equal to K, or alpha square is equal to K square, squaring both sides. Then again, I have to equate with alpha square. That is from equation 3. This is 2 mu by h cross square. This is 4 pi square. Then E is equal to this equation. By solving this equation, we get like this. But according to de Broglie wavelength, lambda is equal to h by mv. Then eliminate lambda here. Then finally we'll get a kinetic energy equation. The kinetic energy is converted in terms, written in terms of momentum. Here the energy of electrons is only kinetic energy, so the electrons are free electrons, indicate the nature of the conductor. Here the potential well indicates the nature of the insulator, because here potential is there. Here the kinetic energy of the electrons indicates the nature of the conductor. Then this is the diagram. These are the energy bands. These are called allowed zones. These are forbidden zones. Then number of electrons are there when the potential is decreasing. That means at nearby this particular origin, it forms a thin, a narrow band. From the away from the first band, the width of the band increases and the gap between bands are decreasing. So we know the conduction band and valency band. So these are the origin of bands formation here. So this is very important question for UG students. In this question, this equation is very important. You have to write this. Before this equation, you have to by heart here to here. You can prove. Then don't prove this because your time is very limited in the examination. So you remember this equation and take the case study. That is p tends to infinity. This is first case. P tends to 0. This is the second case. Like that, I have to solve. Basing on this equation only, we can solve Brilliant Jones also. Brilliant Jones. Okay. So uh, carefully read this question and try to write once, then you will be remember the here this question having two solutions. One is potential Wells solution, another one is kinetic energy solution, that is kinetic energy formula. Okay, don't forget and remember this and subscribe my channel to get updates. Thank you.